All right, today we're diving into the story of a microscopic villain, a really dangerous superbug that thrives in the one place we're supposed to feel the safest, the very places we go to heal.
I mean, just think about that for a second. It's a deeply unsettling thought, isn't it? But it points to a very real problem: healthcare-associated infections, or HCAIs. These are the infections you pick up inside a hospital or a clinic that you didn't have when you first walked through the doors.
And look, the scale of this is just staggering. Over 90,000 deaths every single year are tied to these infections. It's like a silent epidemic happening right inside the walls of our healthcare system. And today, we're going to meet one of its most notorious agents.
So it's time to profile the main culprit here. Its full name is Clostridioides difficile, but you've probably heard its infamous nickname, C. diff.
So what exactly is C. diff? Well, it's a gram-positive spore-forming bacterium. Now, gram-positive is just a lab term that tells us it has a thick cell wall. But the phrase you really want to pay attention to is spore-forming. That's its superpower, and we'll unpack that in just a minute.
And you know, like any good villain, it recently updated its alias. For years, everybody knew it as Clostridium difficile. But then, some new genetic analysis showed its family tree was a little different than we thought. So, it got reclassified into the Peptostreptococcaceae family and was given a whole new genus name, Clostridioides.
Now, here's what's so fascinating about C. diff. It has this core characteristic. You could even call it a fatal flaw, that it has brilliantly turned into its greatest strength. It is an obligate anaerobe. That's the scientific way of saying it literally cannot survive where there's oxygen. For C. diff, the air we're breathing right now is pure poison.
To put that into perspective, most bacteria you've heard of, like E. coli, are facultative. They can kind of take or leave oxygen, they're flexible. Others, like Helicobacter, are microaerophilic, meaning they just need a tiny bit of oxygen. But C. diff is in this hardcore obligate anaerobe club because it's missing some key enzymes, things like superoxide dismutase and catalase. These are the tools other bacteria use to detoxify oxygen. So this weakness forces C. diff to live in oxygen-free zones, like deep inside our gut.
Okay, so if oxygen is literally poison to this thing, how in the world does it survive out in the open, on hospital bed rails and doorknobs? Well, it has two incredible secret weapons: an impenetrable suit of armor and a set of really potent toxins.
Let's talk about that armor first. It's called an endospore. Whenever conditions get harsh, like, when there's oxygen around, C. diff transforms into this dormant state. It's not really living in the active sense, but it's definitely not dead. It's just waiting. It really is the ultimate survival pod.
And let me tell you, this is not your average armor. This endospore is unbelievably resilient. It laughs at alcohol-based hand sanitizers, a lot of common disinfectants, and being dried out. Get this, it can even survive being boiled for up to 20 minutes and can stay dormant, just waiting, for years. The key to all this toughness is one very special chemical compound.
That secret ingredient is called dipicolineic acid. What it does is amazing. It gets into the spore's core and teams up with calcium to lock away all the free water molecules. This extreme dehydration is what makes the spore so ridiculously resistant to heat. It also wedges itself into the bacteria's DNA, acting like a shield to keep it from unraveling. It's just an incredible piece of natural engineering.
Okay, so once C. diff gets inside a person and feels safe enough to come out of its armor, it unleashes weapon number 2, its toxins. The main culprits are Toxin A, or TCDA, and Toxin B, or TCDB. And some of the really nasty strains produce a third poison called binary toxin, or CDT. These are the things that actually make you sick.
So, we've established we have this heavily armored bacterium armed with powerful toxins. But how does it actually launch an attack? Well, it needs the perfect opportunity. It waits for our body's own defenses to be down. And here's how that whole devastating cycle plays out. It starts with disruption. A patient is on broad-spectrum antibiotics, which unfortunately wipe out not just bad bacteria, but all the good protective bacteria in their gut. Then, they accidentally ingest some of those super resilient C. diff spores from the environment. Those spores cruise right through the stomach acid. Once they hit the now unprotected gut, they germinate, waking up and turning back into active bacteria. From there, they multiply and start pumping out Toxin A and Toxin B, which destroy the cells lining the colon. This causes severe diarrhea and a nasty inflammation called pseudomembranous colitis. And finally, that diarrhea sheds millions of new spores back into the environment, ready to start the cycle all over again.
Now you have to understand, C. diff isn't just one single bad guy. It's more like a criminal organization with different crews or strains. And scientists need a way to track them, especially the ones that are way more dangerous than others.
So how do they tell these different crews apart? They use a method called ribotyping. Think of it like genetic fingerprinting, but for bacteria. All bacteria have genes to build their little protein factories called ribosomes, and while the core genes are the same, the DNA in between them varies. By analyzing those variations, scientists can identify and track specific strains as they spread.
And that fingerprinting brings us to a couple of the most wanted criminals in the C. diff world. First, there's ribotype 027. Its alias, the hypertoxigenic strain. It has a mutation in a gene called TCDC that basically acts like a broken off switch for toxin production, so it just churns out massive amounts of toxin A and B. Then there's ribotype 078, the hypervirulent strain. It has a similar mutation, and it produces that extra binary toxin, CDT, which makes it even more dangerous.
Okay, so the picture looks pretty grim, right? We've got this super resilient, highly toxic bacterium that even has hypervirulent strains. How on earth do we fight back? Let's look at the battle plan.
All right, first things first, you have to know what you're fighting. Diagnosis is absolutely critical. Most modern labs use a two-step process. They often start with a super-sensitive PCR test, also called a NAT, that looks for the C. diff toxin genes in the DNA. If that comes back positive, they confirm it with a second test, like an ELISA or EIA, which checks for the actual toxins themselves or a C. diff enzyme called GDH. Using both tests gives you the best accuracy. But this leads to the real kicker, the central paradox of this whole thing. The problem was started by antibiotics wiping out the gut's natural defenses. And yet, the standard treatment for a C. diff infection is more antibiotics. Now, sometimes this works, but for a lot of people, the C. diff just comes roaring back as soon as the treatment stops. So how do you break that vicious cycle? Well, the answer is actually pretty elegant, and frankly a little shocking. You don't just keep trying to kill the bad guy. You rebuild the community of good guys that was wiped out in the first place. You fight a bad microbe with an army of good ones.
This revolutionary idea is put into practice with a procedure called a fecal microbiota transplant, or FMT for short. And yeah, it's pretty much exactly what it sounds like. A complete, healthy community of gut microbes from a healthy donor is transferred into the patient. This instantly restores that protective barrier in the gut, leaving no room and no resources for C. diff to take hold again. For patients stuck in that cycle of recurring infections, this approach has an incredible success rate.
You see, a healthy gut isn't just an empty tube. It's a bustling metropolis of trillions of microbes, and we're even starting to identify specific heroes in that population. For example, there's a bacterium called Clostridium scindens, actually a relative of our villain, that produces compounds that stop C. diff spores from ever germinating in the first place. It's a powerful reminder that sometimes the best defense against a superbug isn't just a stronger drug, but a stronger, healthier ecosystem. The battle against C. diff really shows us the delicate balance inside our own bodies and the amazing solutions we can find when we work with nature, not just against it.